Yeah. P is equal to given. P is equal to how much? 8 kVA. Then that voltage is 400 by 120, na?
Yes,
For
sir.
clarity, yeah. Then V1 is equal to 400 volts and V2 is equal to 120. Then F is equal to 50 Hz. Then OC test results is given, right? OC test, yeah, that is in OC test results 120 volts. Then V naught 120. Then I naught OC test current values are given 4 amps. Then P naught OC test power losses 75 watts. Then SC test results. These are the OC test results. Then SC test results, that is VSC voltage, that is 9. Then ISC, that is 20 amps. Then PSC, right? In OC test we will get that iron losses. Gurtunda, while doing the OC test we will get the iron losses. While doing the SC test we will get that copper losses. That is how much? 110 watts. Yeah. So what we have to calculate? Calculate the voltage regulation and efficiency at full load, and power factor is, that is cos pi 0.8 lagging. Voltage regulation. So what we have to calculate? Required data is first bit voltage regulation, and second bit we have to calculate uh, yes, second bit efficiency. Efficiency we have to calculate. These are the given. So here, that is, see, Z is equal to, solution is we know that Z is equal to, what is that? In AC, I is equal to V by Z. Then Z is equal to V by I. Then ZSC. From the short circuit, we can calculate the Z value, right? Then ZSC is equal to, right, VSC by ISC. See, according to the standard formula, Z is equal to V by I. So ZSC is equal to, means short circuit impedance, that is equal to VSC by ISC. Then VSC is how much here? 9.5 by ISC, that is 20. How much it is? 0.475, right? Then in the short circuit test, we can calculate that copper losses as well as the circuit parameters. These are the parameters ZSC, then RSC. We know that, uh, yeah, power PSC is equal to ISC whole square into RSC. This is another formula. P is equal to I square into R. That is, P is equal to I square into R. So PSC, ISC, RSC, right? Then from this equation, RSC, that is RSC is equal to, we know that PSC value by ISC whole square. PSC is how much? Right here 110, then ISC 20 whole square. how much it is? 0.275 ohms. Once we know that the PSC and ISC, sorry, ZSC and RSC, we can calculate that from that according to the standard formula. That is, what is the standard formula? Z is equal to under root of R square plus X square. So from this formula, ZSC is equal to under root of RSC whole square plus XSC whole square, right? Then now here we know that ZSC and RSC, then XSC whole square or XSC is equal to what is that? Under root of what is that? ZSC whole square minus RSC whole square. What is the ZSC value? Under root of 0.475 whole square minus 0.275 whole square. How much it is? How much it is? 0.3873 ohms. Right. Yeah. Yes. So here, whatever this calculated value, ZSC, RSC, XSC, right? Here it is either it is in the primary side or secondary side. This ZSC 2 or RSC 2, XSC 2, or it is primary side. That data we can find out. The meters are on HV side. In the problem is given, the meters are in HV side. So whatever the voltages are given here, right? So HV side, what is the voltage here? Means in the 400 by 120. It means it is the primary side HV or secondary side HV. ఇక్కడ హెచ్వి అంటే ప్రైమరీనా సెకండరీనా? ప్లస్ జస్ట్ ట్రై టు అండర్స్టాండ్ దట్. హై వోల్టేజ్ ప్రైమరీ సైడ్ ఉందా, సెకండరీ సైడ్ ఉందా? గైస్, ఆర్ యు గెటింగ్ మై వాయిస్? వాయిస్, is this my voice is audible?
Yes,
Yes.
sir.
Yes, sir.
ఫస్ట్ నుంచి క్లారిటీగానే ఉందా? ఎవరు సపోర్ట్ చేయరేంట్రా? This is not a regular class. If you are not interested, why are you time wasting here? Please do not waste your time. ఇక్కడ అటెండెన్స్ లేదు, ఏమీ లేదు, తొక్కతోలు ఏమీ లేదు. పర్ఫెక్ట్గా ఇంట్రెస్ట్ ఉంటేనే ఉండండి, లేకపోతే వేరే ఏ వర్క్ అన్నా చేసుకోండి. మీకు వేరే సబ్జెక్ట్ ఇంట్రెస్ట్ ఉంటే వెళ్ళి వేరే సబ్జెక్ట్ చదువుకోండి. ఎందుకు ఈ పీక్ టైంలో కూడా టైం వేస్ట్ చేసుకోవడం, ఉట్టిగానే లాగిన ఎక్కడ ఉట్టిగానే కూర్చోవడం ఏమొస్తుంది? ఐఎమ్ నాట్ టేకింగ్ ఎనీ అటెండెన్స్, రైట్? జస్ట్ whoever have the interest, please, those people can stay here. If you don't have the interest or something else, whatever, I'm not asking any reason. Please, you can leave and you can do your work. So here 400 volts by 120 volts. So which is high voltage here? Primary side or secondary side?
Primary.
Primary.
So it is
Get to
primary side. So it is a primary side. That's why whatever these parameters we are getting here, ZSC1, RSC1, XSC1. These are all the parameters in the primary side. So primary side current. So that is current is equal to in apparent power, that is apparent power P is equal to V into I. So if it is primary side, then primary side I1 is equal to P1 by V1. P1 is how much here? How much power is given? That is 8 kVA. 8 into 10 to the power 3. And what is the voltage here? 120. Sorry, primary side. What is that voltage? 400 volts. Primary side voltage, it is 400 volts. Right? Then, yeah. Then what is the current here? 20 amps. Right? So this is the primary current, 20 amps. Then power factor is given, copper losses is given. Then regulation. What is that regulation calculated? So here I am now calculating regulation in the primary side. Regulation, that is right, I1 into what is the regulation formula? R01. So this is RSC. This is nothing but this is R01. This is X01. This is Z01. Then R01 into cos pi 1. First regulation, what is that power factor? Power factor is given 0.8. 0.8 power factor lagging. So it is lagging. That's why plus. If it is leading, actually formula is plus or minus X01 sine, right, by that is V1, right, into 100 if it is percentage. Here plus sign indicating for lagging power factor, minus sign indicating for leading. Yes, no?
Sir, your voice is breaking.
So break వస్తుందా? సెకండ్ వైఫ్ డిస్టర్బెన్స్, ల్యాన్ కనెక్ట్ చేస్తా, జస్ట్ 1 second. Now
It's okay, sir.
yes, so now are you able to see the whiteboard?
Yes, sir.
Yes, sir.
Okay, so here now in that book it is clearly given current is just we calculated the current value. This is the current value. Then R01 cos pi 1, it is 0.8. Then here it is plus sign 1, that is 0.3873 sin pi. If it is cos pi is 0.8, then I is the cos inverse of 0.8. Then whatever that 36.6636 ఏదో వస్తుంది, 36.36 something, then sin 36.36, that is 0.6. So it is directly, if the cos pi is 0.8, sin pi is equal to 0.6. So here it is 0.6. Then V1 value is given, what is that? 400 volts. Then you will get that regulation, right? Then efficiency. Efficiency is very clear. Efficiency formula, what is that? Output power in kW. Output power in kW by output plus iron losses plus copper losses into 100. So output power in kW. kVA is how much? 8 kVA. 8 into, this is kVA. Transformer output power at full load in kVA is 8. In kW, kVA into cos pi. Cos pi is how much? 8 into 0.8 into 10 to the power 3. మళ్ళీ ఇక్కడ కన్ఫ్యూజన్ అవ్వకండి. సారీ, 8 into 10 to the power 3 into 0.8 divided by 8 into 10 to the power 3 into 0.8. Iron losses, Pi and Pc is given. What is that Pi value? Pi value 75 and 110. 75 plus 110 into 100. This is the efficiency. Emma, B3. Is it
Yes,
clear?
sir. Understood. Yes, sir. Thank you, sir.
Yeah. ఇంకేమైనా డౌట్స్
సార్
ఉంటే అడగండి.
అక్కడ 120 వోల్ట్స్ దగ్గర మనం
మ్మ్.
400 బై అక్కడ వోల్టేజ్ మనకి 400 బై 120 ఇచ్చారు కదా సార్.
మ్మ్.
మనము రేషియో ఫామ్ టెస్ట్ లో ట్రాన్స్ఫార్మ్ రేషియో ఫామ్ టెస్ట్ లో V2/V1 కదా సార్ తీసుకునేది.
ట్రాన్స్ఫార్మర్
రేషియో ఫార్ములా ఉంది కదా సార్, V2/V1 = N2/N1. అలా కాదా సార్ వోల్టేజ్ తీసుకునేది?
అప్పుడు మీకు సపోజ్ at a 5 kVA transformer, suppose, or a 10 kVA transformer, comma 11 kV by 440 volts. It means here 10 kVA is the power, V1 is the 11 kV volts, and V2 is the 440 volts. This is not the K value.
Yes, sir.
This is not the K value. It is just voltage
Okay.
values.
ఓకే సార్. థ్యాంక్
Yes, ఇంకా rule number 47. Bhavya garu, any doubts? టైం వేస్ట్ చేసుకోవద్దు. నెక్స్ట్
ఒకసారి ఓసీ టెస్ట్ ఎస్సీ టెస్ట్ లో హై వోల్టేజ్, లో వోల్టేజ్, ప్రైమరీ సైడ్, సెకండరీ సైడ్ ఒకసారి ఎక్స్ప్లెయిన్ చేయండి సార్.
OCSC టెస్ట్ లో
హై వోల్టేజ్, లో వోల్టేజ్ ఎటు సైడ్ ఉంటుంది ఒకసారి ఎక్స్ప్లెయిన్ చేయండి సార్.
ఎట్ సైడ్ కాదు, ఇక్కడ వోల్టేజ్ వోల్టేజ్ రేటింగ్ ఇచ్చారు 400/120 volts అని, 400/120 volts. So when compare this two voltage 400/120 volts, which is high voltage?
400.
Yeah, that's why here in this problem primary is the high voltage and 120 is the low voltage. ఇక్కడ క్లియర్ గా see here the following readings were obtained from OC and SC test 400 volts. So calculate the voltage regulation efficiency of the full load at 0.8 power factor lagging. So now all the meters while doing the OC test and SC test, all the meters we are connected in the primary side. అవునా కదా? మీకు ట్రాన్స్ఫార్మర్ ఓసీ టెస్ట్ ఎస్సీ టెస్ట్ ల్యాబ్లో చేయించాను, గుర్తుందా? All the meters we are connected in that primary side. So here primary side means high voltage side or low voltage side?
High
High
voltage.
voltage side. So here we are getting that primary parameters, whatever those parameters. So by using the short circuit test, we are getting primary parameters, that is ZSC, RSC, whatever XSC. So these are the total parameters referred to primary. That's the point.
Okay, sir.
ఇందాక
Sir.
ఎవరో నోడల్ ఎస్
సార్ మీకు వాట్సాప్ లో ఒక పిక్ పెట్టాను చూడండి సార్ 5A చెప్పారా అందులో?
అనుకున్నా ఇంత గట్టిగా మొత్తుకున్నావు అంటే నువ్వే అయి ఉంటావని. 5A.
Yes sir.
Explain how the sinusoidal waveforms represented as phasor quantity with example. అదేనా?
Yes sir, అదే.
Sinusoidal waveforms represented as phasor quantity with example అంటే ఏం లేదమ్మా, మొన్న ఒకసారి చెప్పాను. If the two alternating quantities are in phase అనుకోండి, ఎగ్జాంపుల్ తీసుకొని see in this question to ఈ క్వశ్చన్ చేయాలంటే మీకు ఫస్ట్ అది ఏంటి, సబ్జెక్ట్ నాలెడ్జ్ ఉండాలి. సపోజ్ if these two alternating quantities right, this is one and another one, right? Suppose it is V and it is I, right? If these two alternating quantities 0 pi 2 pi, so now if these two alternating quantities voltage as a reference, that is V is equal to Vm sin omega t, then I also here Im sin omega t. It means current I is in phase to the voltage V. So here this is current I, both are in phase. This is the phasor diagram. So here you have to write down if the two alternating quantities, right, are in phase to each other, means here while considering the voltage as a reference, current is also follows the voltage V, right? And the here points, observing points is angle pi is equal to 0 degrees. Pi is equal to 0 degrees. Then here when the pi is equal to 0 degrees, then what is the cos pi? Cos 0 is how much?
90.
Cos 0 value
1.
Then power P is also, that is V into standard formula V into I into cos pi, right? Then cos pi is equal to 1. Then power P is equal to Vrms into Irms. This is one. And another one also we can consider, that is lagging by 90 degrees undankondi. So here it is reference, then voltage, then here it is another quantity, so here V is equal V is equal to Vm sine omega t. Then what about current here? Current is here, the angle is pi. That pi is equal to pi by 2. Here it is pi, then here maximum value, here pi is equal to pi by 2. Then I is equal to Im sine omega t minus pi by 2. So then what is the phasor representation? Voltage V. I am considering voltage as a reference. Then what about the current here? Current is lags to the voltage by an angle of pi by 2. Then another one also you can consider, that is another one is the leading. You got the point?
Yes, sir.
Yeah.
సార్ ఎంసీబీ ఎంసీసీబీ డిఫరెంటా సార్ రెండు ఒకటేనా? 11A చూడండి సార్ మీకు పెట్టిన పిక్ లో.
రెండు ఒకటే ఎట్లా అవుతుంది అమ్మ, అక్కడ క్లియర్ గా రాశాడు.
సార్ మీరు క్లాస్ వర్క్ లో ఎంసీబీ ఒకటే రాపిచ్చారు మరి.
మోస్ట్లీ ఎంసీబీ ఒకటి చదవండి. ఈఎల్సిబి ఎంసీబీ అవి చాలా, ఈ 5th యూనిట్లో డైరెక్ట్ క్వశ్చన్ ఎంసీబీ ఈఎల్సిబి అవి చదవండి బాగా. ఇంకా ఇక్కడ ఇంకా
సార్ 8A కూడా.
ఎస్
సార్ 8A సార్ ఫేస్ స్లిప్ రింగ్ ఇండక్షన్ మోటార్.
యా, ఇండక్షన్ మోటార్ కన్స్ట్రక్షనల్ డీటెయిల్స్ ఏమేం పార్ట్స్ ఉంటాయో. ఇండక్షన్ మోటార్స్ మెయిన్లీ రోటర్ వైండింగ్, స్టేటర్ వైండింగ్.
ఓకే సార్, అర్థమైంది.
ట్రాన్స్ఫార్మర్ లో కెపాసిటీ లోడ్ డయాగ్రామ్
ట్రాన్స్ఫార్మర్ లో
కెపాసిటీ లోడ్, ఇండక్టివ్ లోడ్ అని మనం ఒక డయాగ్రామ్స్ వేసుకున్నాం కదా సార్. అందులో కెపాసిటీ లోడ్ డయాగ్రామ్ చెప్పండి సార్. కెపాసిటీ అండ్ ఇండక్టివ్.
ఆ నోట్స్ ఉందా నీ దగ్గర?
yes
ఏం అర్థం కావట్లా, అన్ని పిచ్చి గీతలాగా అనిపిస్తుందా?
మీరు అప్పుడు ఫస్ట్ ఏమేమి కన్సిడర్ చేయాలని చెప్పారు కదా సార్, అవి గుర్తులేవు.
అప్పుడప్పుడు నోట్స్ ఓపెన్ చేస్తే గుర్తుంటుంది. సో ఓకే, సో హియర్ when the transformer connected here, when the load is connecting, here voltage is V2, here current is I2. So initially first we have to transformer with no load, we have to draw it. No load దగ్గర ట్రాన్స్ఫార్మర్ ఎలా ఉంటుందని. సో దెన్ V2 as the reference, V2 as the reference, right? One second, not this one. Okay, so the secondary side magnetizing. Yeah, okay, got it. Yes, primary side we have the V1, Here current is first initially it is I naught current, that is Im plus I mu. Then here induced EMF, here induced EMF E2, then here I2. So here first magnetizing Im here. So when we are given supply voltage, right, the no load current, initially it is no load. Here the load is not connected. When the load is not connecting, here I naught, no load current will flows, and this no load current is split into two parts, magnetizing current and
Then
I mu. That is I mu. Im purpose is to magnetize the transformer core. I mu purpose is to overcome the iron losses. So here pi m flux is always in phase to the Im. Here we have the Im. Then the voltage, this coil, whatever this transformer coil, we are given supply voltage. This voltage is always leads to the, means it is a inductive coil. In inductor, what is that? Current is lags to the voltage by 90 degrees. అదే కరెంట్ ని రెఫరెన్స్ తీసుకుంటే వోల్టేజ్ ఏమవుతుంది ఇక్కడ? Voltage is leads by 90 degrees. So here we have the voltage V1. So when voltage V1, the I mu is always in phase to the supply voltage. So here we have the I mu. Then the vector sum of I mu and Im, that is I naught. This is your I naught. Then your induced EMF is always equal and opposite to the supply voltage according to Lenz's law. Your induced EMF always equal and opposite. So here it is E1, right? If the losses are negligible, here V1 almost equal to E1. In ideal transformer, V1 is exactly equal to E1, but in a practical transformer, it is almost equal. Then E2 is also in phase to the E1. It is also opposes the supply voltage. So where have to draw that? Here it is E2. Right, this is the transformer under no load. So now here E2 is equal to V2. So here at the same time here I am drawing E2 place lo nenu V2 అని రాసుకుంటున్నా. E2 is equal to V2. So if the load is resistive load, in resistive load, V and I are in phase. Yes or no?
yes, sir.
Then where have to draw the I value, I2 value? Here somewhere. Here it is I2, right? Then again when the load is connecting, here I2 dash term will come. That is here I2 and here I2 dash. Then I2 dash is exactly opposite to the supply voltage. So here it is I2 dash. Then I naught plus I2 dash, that is equal to I1. So I naught ikkada undi, I2 dash ikkada undi. Then vector sum of these two quantity, that is nothing but I1. This is resistive load. If the load is inductive load, right? If it is the load is inductive load, Please be careful. These terms are same. What are those terms? Here pi m, then here it is im, then here it is v1, then here it is I mu, vector sum of these two quantity, that is I naught, then here it is here it is E1, then here it is E2, E2 is equal to V2. Up to this point is same. But in that, if it is the inductive load, in inductive load, pure inductive load, current is lags to the voltage by 90 degrees. But if it is some inductive load, then here current is lags. Here it is I2. Then I2 dash, exactly 180 degrees opposite to the I2. So here we have to draw that I2 dash. This is I2 dash. Then vector sum of these two quantity. This is your I1. That's all. Adhe idi inductive load. This is inductive load. If it is capacitive load, what will do? This I2, whatever this I2, it will comes here. And opposite, 180 degrees opposite, that will comes exactly 180 degrees opposite. This is I2 dash. Then the vector sum of I0 and I2 dash. This is your I1. This is for capacitive load. Yeah. Inka? ఇంతకుముందు ఎవరో ఒక ప్రాబ్లం పెట్టారు అబ్బా, అది మళ్ళీ కనిపించట్లేదు చాట్ బాక్స్ లో.
నేను పంపిస్తాను సార్, డిలీట్ చేసిండు వాడు.
One second, tablet is covered. Where is my tablets? ఏంటి సార్? క్లాస్ నడుస్తుంది. డౌట్స్ అడుగుతున్నారు.
సార్ సింక్రోనస్ జనరేటర్ వర్కింగ్ చెప్పండి సార్.
Huh?
సింక్రోనస్ జనరేటర్ వర్కింగ్.
Synchronous generator, yeah. Synchronous generator is nothing but synchronous generator is nothing but AC generator, or we call it is alternator. Synchronous generator anna, AC generator anna, alternator anna okate, right? This alternator or synchronous generator or AC generators, we are using at large quantity of the power generation. Large quantity of the power generation. Large quantity of the power generation. Mostly that is in that power generating stations. power generating stations. Those are in Nagarjuna Sagar, Srishailam, or thermal, Ramagundam, NTPC, KTPS. These are all the power generating stations. In that power generating stations, we are using that alternator. So here DC generator ki AC generator ki difference ఏందంటే in the DC generator, both generator, either it is AC generator or DC generator, it works based on that Faraday's laws of electromagnetic induction principle. It works based on Faraday's laws of electromagnetic induction principle. What is that Faraday's law? Whenever a conductor cuts the magnetic flux, an EMF is induced in that conductor, and that induced EMF is directly proportional to rate of change of flux. So in DC generator, armature conductor. So in DC generator, these are the magnetic flux, north pole and south pole, right? Here magnetic flux flowing from north pole to south pole. నేను ఏసీ జనరేటర్ చెప్పమంటే ఈయన డీసీ జనరేటర్ చెప్తుండేది అనుకోవద్దమ్మా, ఇది అర్థమైతే నాకు అర్థమవుతుంది. సో హియర్ మ్యాగ్నెటిక్ ఫ్లక్స్ ఆర్ ఫ్లోయింగ్ ఫ్రమ్ నార్త్ పోల్ టు సౌత్ పోల్. Then here just I am putting conductor, rotating armature conductor here. Rotating armature conductor. So when this conductor cuts those magnetic flux, those are the magnetic flux. When this rotating conductor cuts this magnetic flux, EMF is induced. This is happens in the DC generator. But when comes to the AC generator, here we are using very high amount of the armature conductor in AC generator. So here we are using stationary armature conductor and rotating magnetic field. The only reason is here we are in AC generator, we are using more number of armature conductor. Here we are using huge quantity of the armature conductor because of we have to generate more power. The generating power is more. So here to rotate this high amount of the armature conductor, here itself some power is means losses. So armature conductor ni rotate cheyalante, to rotate those armature conductor we require some power. So that's why what I am doing here, those armature conductor is stationary and I am rotating the magnetic field. So whatever, if the rotating magnetic field is there, armature conductor stationary undi, then chuttu magnetic field rotate ayina same principle kada. Those are flux cuts the conductor. Yes or no?
Yes, sir.
Yes, sir.
Right? Same Faraday's laws is happens. Right? That's the principal operation of the AC generator. So what is happening in the AC generator? Here we are using stationary armature conductor and we are using rotating magnetic field, right? Whereas the stationary armature conductor cuts this rotating magnetic flux and EMF is induced according to Faraday's law. So why we are using the stationary armature conductor means here to get, here we are using huge amount of the armature conductor, and to rotate all this armature conductor we lost some power. So to avoid those losses, right, and we are using stationary armature conductor. Inka yeah, someone sent సో ఇది వన్ ప్రాబ్లమా?
ఎస్ సార్.
ఓకే, సో దీన్ని కూడా నోడల్ అనాలిసిస్లో చేద్దాం మనం. నాకు వాట్సాప్ చేసినావా ప్రాబ్లం?
చేసిన సార్.
Yeah, that problem is నోడల్ అనాలిసిస్లో చేయొచ్చు ఈ ప్రాబ్లం. Four volts, 1 volts. Polarities are important here. 3 volts. నేను polarities na wrong గా పెట్టుంటే చూడండి. Here it is 6 amps. Then here it is 4 amps. Then here what is the 14 ohms? Idi 14 ohms, 7 ohms, and here also 7 ohms. Here it is 2 ohms. Here it is 3 ohms. So here in this problem we will consider these are the, yeah, this is the zero node. Then here it is V1, V2 and V3. These are the three nodes. On the three nodes I am putting V1, V2, V3, right? So at each node, right, what I said, if the direction current, all the currents are living, right? So here in this node point, what are the elements are joined? 4 amps is joined, 14 ohms is joined, and here 6 amps is joined, right? Am I clear? So here 4 amps current already it is given, it is entering, and 6 amps is also entering. Then sorry, 6 amps also leaving. Then here current is, just I am assuming here it is some I1 current, and here it is I2, 6. So at node 1 I am writing that equation. At node 1, at node 1 current is entering. Which current is entering here?
4 amps.
4 amps, right? Entering current is equal to leaving current. What is that leaving current here? I1
6 amps.
plus 6. I1 plus 6. Am I right? Then what is I1? I1, how to write down I1? Here in this I1, current is equal to, what is the formula? Voltage by V by R. So from this point to this point, the potential difference, so that is, yeah, V1, then here again plus 2 minus 4 volts is there, voltage difference. Plus 2 minus unte em తీసుకోవాలి నేను? Minus 4, then minus V2 divided by here voltage by resistor 14 ohms and 7 ohms. 14 plus 7 is how much? Right?
21.
That is the I1. So here 4 is equal to V1, right, minus V2 minus 4 by 21 plus 6. Right? This is equation 1. ఇక్కడ V1 V2 టర్మ్స్ సపరేట్ చేయండి. నేను ఈక్వేషన్ రాయడం వరకు చెప్తున్నా. రైట్? Then next V2. Sorry, at node 2. At node 2, just observe the, see, here we don't have any current equations. అవునా? ఇక్కడ కరెంట్ డైరెక్షన్స్ ఏమీ లేదు. సో assume that all are living. Right? ఇక్కడ some లేకపోతే లేకపోతే ఇక్కడ I1 ఆల్రెడీ అనుకున్నాం కదా, I2 I3, right? Some I1 అనుకోవచ్చు ఇక్కడ ఆపోజిట్ డైరెక్షన్ కాబట్టి. Right? So here all currents are living. So that is I1 plus I2 plus I3 is equal to 0. Then I1 is equal to ఎలా రాసుకోవచ్చు ఇక్కడ? I1 V2 voltage is there. Then V2 ఇక్కడ -2 ప్లస్ ఉంది, 4 volts. This 4 volts. -2 ప్లస్ ఉంది. ప్లస్ తీసుకోవాలా మైనస్ తీసుకోవాలా? ప్లస్ 4 minus V1, right? Divided by what is the resistance here? 14 plus 7. That is I1. Then I2 plus I2. I2 is equal to here V2. Here again -2 plus. So that's why plus 3 volts minus V3 by what is the resistor here? 7 ohms. Right? Plus V3. I3 what is that? V2 here plus to minus, so that's why -1 by what is the resistor? 2 is equal to 0. Right? That is at node 2. Then at node 3, here already 6 amps from this upper path, 6 amps is the entering, right? So 6 is equal to, right, assume that here it is I2 current, here it is some I3 already వచ్చింది కాబట్టి I4, that is I2 plus I4. Then 6 is equal to, what is I2 here? V3 minus plus to minus, then -3, right, minus V2, then what is the resistor here? 7 plus I4 is equal to, what is that here? V3 volts is there, here 0, that is V3 minus 0 by 3 ohms. So here in each equation V1 V2 V3 terms separate చేయండి. చేయగలరా? చేసేసారా?
చేస్తాం సార్.
ఒక ఐడియా వచ్చిందా?
Yes, sir.
ఇక్కడ ఈక్వేషన్ 1 లో v1 v2 టర్మ్స్ సపరేట్ చేయండి. ఇంకా డౌట్స్ ఉన్నాయా?
సార్ మీకు వాట్సాప్ చేశాను చూడండి.
ఎగ్జామ్స్ ఎప్పటి నుంచి మీకు?
ట్యూస్డే.
సార్ మీకు వాట్సాప్ లో ఒక క్వశ్చన్
చూస్తున్నా. క్వశ్చన్ అంటే ఈ క్వశ్చన్ పేపర్ మొత్తం ఎక్స్ప్లెయిన్ చేయాలా?
లేదు సార్,
పర్టికులర్
2A.
2A
సమ్ సార్.
Ix and By values ఇది సోర్స్ ట్రాన్స్ఫర్మేషన్ ట్రై చేయండి. సోర్స్ ట్రాన్స్ఫర్మేషన్ చేస్తే ఫైనల్గా ఒకటే సోర్స్ ఉండేటట్టు చూసుకోవాలి. సోర్స్ ట్రాన్స్ఫర్మేషన్లో వస్తుందమ్మా ఈ ప్రాబ్లం.
ఓకే.
ఇంకా
సార్ టార్క్ స్లిప్ క్యారెక్టరిస్టిక్స్ చెప్పరా? టార్క్ స్లిప్ క్యారెక్టరిస్టిక్స్.
టార్క్ స్లిప్ క్యారెక్టరిస్టిక్స్ టార్క్ ఈక్వేషన్ మ్యాథ్స్ క్లాస్ ఎన్ని గంటలకు మీకు? 10:25కా? సార్ మీరు బాగా సీరియస్ అవుతున్నారా? మీరు మ్యాథ్స్ క్లాస్ కాకుండా బీడబ్ల్యూ క్లాస్ ఎక్కువసేపు ఉంటున్నారు ఏంటని?
ఏమనట్లేదు సార్.
So here in torque equation గుర్తుందా మనకేమన్నా? That is in the induction motor, that is torque is equal actually torque is directly proportional to flux and armature current. Then finally we derived the torque is equal to tau is equal to 0.5 into Z into
0.158.
that is DC 0.159 into pi into Z into IA into P by A. Am I correct? Pi is the flux per pole in Webers, Z is the total number of armature conductors, IA is the armature current, P is the number of poles, A is the number of parallel path, A is equal to P for lap winding, A is equal to 2 for wave winding. This is for DC motor. But where comes to the AC motor, that is torque is equal to we derived that is S into E2 square by R2 square plus X2 square into R2. I think ఒకసారి చూడండి, క్రాస్ చెక్ చేయండి. యా ఎస్ ఈజ్ ద ఇక్కడ ఎస్ వస్తుంది అనుకుంటా. ఎస్ ఇంటూ
SE2 by root over R square plus SV2 whole square into R2 by root over R2 square plus SX2 whole square.
రూట్ ఉంటుందా?
Yes, sir.
రూట్ క్యాన్సిల్ అవుతుంది అనుకుంటా అమ్మా. రూట్ ఉండకపోవచ్చు.
అప్పుడు K వస్తుంది సార్, కాన్స్టెంట్ K.
కాన్స్టెంట్ కే వస్తుంది. ఫైనల్ ఆన్సర్ నేను చెప్పమంట.
K into E2 square by R2 square plus SX2 square into R2. Correct sir, K రాయలే మీరు.
Yeah. K is the some constant. హలో, చెప్పండి. ఓకే, పైన ఫస్ట్ ఫ్లోర్లో ఇచ్చేసేయండి. అది కాదు, మీరు ఎక్కడున్నారు ఎగ్జాక్ట్లీ ఇప్పుడు? ప్రీవియస్గా వచ్చి ఉంటారు కదా మీరు.